Hi folks, Paul here, back inside my Leaf, and a few people have asked me for some more detail on how to build one of these state of charge displays. This is for the 2011-2012 Leafs that don't have that feature in the car, so this is going to be a how to build it. As a quick recap, so what this does is it shows the state of charge in the battery, and I've also got kilowatt hours. When the car was new, it would have 21 kilowatt hours when it was fully charged, and now my car, which is 10 years old, it can hold a maximum of about 15.5 kilowatt hours when it's fully charged. So this little display fits inside the dash over the top of the weird trees thing. I've got several different pages worth of display options. Depending on what is of more interest to you, you can change the pages. And to change the pages, you need to use a weird combination of things in the climate control. So if you turn the climate control on, have the mode be blowing air onto your feet only, and then go into recirculation option, which is a weird combination. Recirculating air onto your feet only. When you're in that mode, then you can start editing the pages and the options on my display by playing with the number of fan units. So once you're in the mode, the display will have a dashed line around the edge, and one fan blade is just the state of charge and the kilowatt hours. 2 fan blades is state of charge and gids for the geeky people who want to know how many gids they've got. Then 3 fan blades is just the range, nothing else. 4 is my personal favourite, which is the range plus the state of charge plus the kilowatt hours. So that's quite a nice collection of information. And then the next one up, 5 blades, gives you some geeky information that you might want if you're editing the default values for kilometres per kilowatt hour and max gids. And what these 2 numbers here influence the how the range is calculated, and also the upper limit for the state of charge. So a brand new 2011 Leaf had a number of gids of 184, I think, or something like that, and my capacity has faded over the last 10 years down to 205. And it's worth changing these values to fit the characteristics of your particular car. And then the gear and the eco stuff is just me fiddling with options while I'm programming. You don't really need to know those. So then if we go back into edit mode and we go up to 6 bars, then we get into the option where you can actually edit these 2 values. If you put yourself into drive with your foot on the brake, then you can actually modify this number here either up or down by adjusting the temperature up and down. So if you go all the way up to maximum 32 degrees, then it takes it way up to 7.9 kilometres per kilowatt hour. And if you come way down to the minimum 18 degrees, then you get 5.1. But if I don't want that, I want 6.3, We're in midwinter here, and that's about the average that my car does. I just reset this value yesterday, so it's not accurate for the whole month. And then if you go from drive down into eco mode, then this pops down and you can edit this value here, up and down. Then if you move away from that page, down to page 4 is my preferred one, you get back to that page there, turn the climate control off, and it will stay like that. And it retains that value in the EEPROM, so every time you start the car it will show that screen. One of the limitations of this project is that my programming skill is not that great, so you might have noticed that it took a while for the data to initially show when I turned the car on. I haven't worked out what is going on there. I'm more interested in solving other issues before I try and solve that. The other issue with this project is that I'm also working on this project, and this is kind of taking all my attention because this is possibly even cooler. I'm quite pleased with how this is coming along, but it does mean that I'm not spending much time on this. I would love to solve the problem of the slow startup. We'll see. Anyway, let's get stuck into it and see how to make one. And here is what you will need: an Ov2 plug, a 12 volt to 5 volt voltage regulator, a MCP 2515 CAN bus module, an Arduino Pro Micro or a Pro Mini, and they are basically, if I've got this around the right way, yes, they're basically pin compatible for all the pins that I use in this project. I started out using one of these because that's what the previous project that I'm piggybacking on used, and then I migrated to the Pro Micro because it's got USB built in, which just means one less thing. If you use the Mini, you need a programmer USB to serial doofer, and that's just a little bit more hassle than I could be bothered with. But these are ever so slightly cheaper, and they use ever so slightly less power. So, a reasonable choice. This is easier. And you need those, and then you need a display. And your choices are a 0.96 inch OLED SPI interface display, or a 1.3 inch OLED SPI display, or a 1.54 display. These are really easy to get. These are slightly less common, but this is the biggest that you can fit into a 3D housing that will fit inside the dash. For these, you have to separate the actual, this is how they come from eBay or AliExpress. You have to very carefully separate the display from the backing module in order to have this part inside the dash and this hanging outside the dash, and then you connect to that. And I was never able to find an elegant way of doing that, so it just kind of hung out there, and eventually it split and stopped working. So whilst that's the largest display that I could fit inside the dash, it's not a robust solution. And this one is easy to get, but it's slightly too small for the number of data that I want to put on the dash, so that's no good. And this 1.30 inch display is just perfect. 128 by 64 pixel OLED display, fairly cheap, they're fantastic. In order to fit them in my 3D printed frame, you have to sand or grind down this corner of the PCB and a little bit of this corner. And it just fits, so that's quite nice. Then you'll also need some way of connecting all these together, and you can either use a whole bunch of this stuff or mount all these on a board like this perhaps, a prototype board. That is a good solution. Or you can do what I did, which is use Easy EVA, the online tool to design a PCB. It's just a one-layer board. I think it's one layer. It could have been 2 layers, but I got it all on one layer. The micro on standoffs, so if I manage to kill the micro, I can swap it out quite handily. So that's quite nice. And then I've also got a 3D printed box enclosure. I haven't done the lid yet, but that is quite nice. And then in order to connect the display to the board, I am using some ribbon cable like this. You can buy pre-assembled ribbon cables, so that's what I did. These are 10-way ribbon cables on AliExpress. You get them on eBay as well. Those are nice. So what I've basically done is hand soldered this onto the pads on the back of the display. Then I put some black masking tape over it, put the frame over it, and it's held in place with double-sided tape. So when I'm ready to mount this, just peel that off and stick it on. It'll be great. So there's that for the display, like so. That's nice and tidy. USB cable, just a generic USB cable, will work fine for programming it. And then to wire up the plug to the board, in my original vision, I would mount this directly or have one with 90 degrees bend mounted on the PCB, which would be another solution. But it's easier if you separate these two things in the car and with a bit of cable. And I just used an old bit of Ethernet cable and connected that to that. Also, I managed to get the shape of this wrong, so it wouldn't work even if I wanted to. So that is all the bits and pieces you need. There's nothing else hardware-wise that you need to know about. As you can imagine, I've got links to the 3D printed files for these things and these things. Once you've assembled all the hardware, you need to wire them all up as per the wiring diagram that I've provided on my website. And assuming you do a perfect job of that, then the next step is to program the Arduino. So let's do that. Okay, start by popping on to my online diary, which is at myonlinediary.com, and scroll down to the static charge display project page with a nice big image of the wiring diagram. It's all pretty straightforward. The only odd thing here is I'm showing the Pro Mini, whereas these days I'm using the Pro Micro. So the Micro has the same pin out for all the pins that I'm playing with. The only real difference is that it's got this USB connector instead of the serial pins. Otherwise, everything else is absolutely straightforward. So you go and buy all the bits and pieces, then down at software, you will need the Arduino IDE, which you can get from the arduino.cc website. I'm kind of assuming that you've already got this, and already downloaded it and installed and played with at least one Arduino before tackling this project. But even if you've never played with an Arduino, it's not too hard, and there's a million YouTube videos on how to get started. So don't be too intimidated by that. Let's imagine that you've got the Arduino IDE installed. Let's start it up. Here it goes. This is a blank sketch. Before you can run my code, you need to pre-install a couple of libraries, which just means a bunch of software that somebody else has written to do various specific tasks, like talk to the display or talk to the canvas module. So back here I talk about the U8G2 graphics library and the MCP_can library. Now it turns out the U8G2 graphics library is so helpful that it's included in the Arduino libraries manager. Here's the library manager. So loading. If you search for U8G2, enter, it will find the U8G2 library and allow you to install it. I've already got the latest version, but if you came here without having it installed, you can install it there. But I've already got it, so I'm happy there. And the other thing that you want is the MCP_can library, and that unfortunately is not part of this library. You have to install it manually. So the way to do that is to jump on over to the GitHub website and grab the code and download the zip. And I'm just going to save it in downloads. That's done, and while we're here we will also download my code. Download that. Okay, so we've got both of those. We don't need either of those pages anymore. We can go back to the Arduino and we can go include library and zip library. So if we go to the downloads folder and grab that, open that, it will install that library in with all the others. Now in my case it's giving an error because it already exists, so it's not going to load it up for me, but it will for you. So then you'll have everything you need to start with my code. Let's go back to downloads, and here's my one. Now I need to unzip this, so I'm just going to extract here. Boom. And there we go. Now my recommendation at this point would actually be to copy this to the Arduino sketches folder, which should be in Documents, Arduino, and go and look for the version of Leaf SOC with the highest number. So in this case it is version 50, and if you grab that and just drag it over to the Arduino folder, and then you can double click on it and it will load eventually. Now it's going to say I need to create a folder for that to live in, so say yes, and it will create a nice little folder and stick that in it. Now you also need, if you go back to, you need two other things from this folder. You need battery large and battery small. So if we grab that and just toss it over into the new folder that we just created, moments ago. And so now we've got a folder with my program, my Arduino program, the large battery image and the small battery image. And now, if we go over to my program, we can actually close the blank sketch. We don't need that anymore. Okay, so here is the latest version, and you can see it's including a bunch of things. So it's including the U8G2 library. So we've already installed that. That should be good. It requires the MCP_can library. We've installed that, and it also requires the EEPROM library, and the Arduino IDE already has that built in. And then it includes and requires the large battery and the small battery, which we've just done. And then after that, there's a few settings that you might choose to play with, but you don't have to, because you can edit these two default values from the car, so you don't have to fiddle at this point. You could, but you don't have to. So we won't bother. We will just, first of all, we'll run the compiler over it to see if it will compile properly and to make sure that we've got everything that is needed. So it's thinking. If there are any errors, now is the time for it to tell me, but no, none at all. Excellent. So you'll see it's using 75% of program storage space, so it's doing a reasonable job given that there's not that much memory in these devices. So at this point we could just upload that and see if it will actually write to the device, to the micro. Yes, and it's transmitting, and it has successfully uploaded. Okay, so that means that this micro now has all the software you need, and all that we need to do now is plug it into the rest of the system. And in my case, I can do it like that. Plug that in there. I've got the display plugged in. I don't need to plug it into the Ov2 port, because if I plug it into the USB, that is enough to drive everything, including the display. So this is a brand new Arduino. Let's see what happens. Oh, look at that. Alright, so what that means is the micro is successfully talking to the display. That's a good sign. And also the fact that it got past the boot up screen means that it is also successfully talking to the CAN bus module, the MCP2515. What that means is that this can then be wired up for the Ov2 port and plugged into the car, and it should just go. It should just go. Let's try that then. And through the magic of editing, I have already attached the Ov2 plug, and just following the diagram. So let's get that in there. That's good. I won't seal that just yet. Then let's get, is that the right way? No, that's the wrong way. Right. I might just put a little bit of foam in here. A wee bit of foam. We now have a dog. He makes a lot of noise. Right. Okay. Before I seal that in, we should just test it in the meantime. That'll work. Okay, so let's jump in the car. Am I on? Yes. Okay, let's see if it will work in the car. Plug in into the Ov2 port under the steering column. Let's turn it on. All the way. It boots up, so that's encouraging. Now we're just waiting for the CAN data to fly past. Yes! Alright, here we go. That's good. All we need to do now is install it. Good. Alright, to remove this brow piece, you can either use a plastic pry bar or a 3D printed plastic pry bar, or if you have just the right knack, you can use the side of your thumbs and your fingernails to push with your thumbs up and pull with your fingernails, and out it comes like that. This one's a bit harder, so I do normally use a pry bar in this edge here. Now on my car I've done this so many times that it's a bit easier than you should probably find, but anyway, so you want to lever that up and then pull back on this here towards yourself. So pulling up slightly disengages the catch, and pulling back disengages it further. And if you're really lucky, you can pull it out in one go, like that, or you might need to use the pry bar on both sides. Then you'll need a Phillips screwdriver, and be very careful not to drop this down in there because you'll never find it. And as you can see, I've already actually got my display in here, but I'll show you the process. You need to reach back behind this because there's two clips here. So I'll try not to obscure too much. But you pull in towards yourself, and boop, out she pops. In the back here there's a connector, and you need to push down on that lever and then pull it out. Push down and out. And it's always quite awkward. Alright, so now we need to remove this first clear sheet, and it's made of a fairly brittle plastic, so you need to be careful when you're disengaging the clips. You want to do it very gingerly and not force it. So you want to get one out and then the next out. Okay, I think I just about got them all. That one I'm holding out. Okay, so, oh, there we go. Alright, now you also want to be careful not to scratch this because it's pretty susceptible to scratching. And you don't want to get dust on it, and so just try and be careful. Now you want to delve even deeper. The next layer, the next shroud has a clip here, there, 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 and there. that comes off like that. And so here is the innards of the display. If you look really carefully, you can see the window in the black covering, which is where the visual elements come through. So for the tree symbol thing, you'll see a little window, and I've covered that with black masking tape, a nice wide piece of black masking tape. And then the display, a happy little display, use the double-sided tape and stick that onto the masking tape. What this means is that eventually, if you ever want to remove this, you can peel this off the electrical tape and then the electrical tape off this, and then clean it, and you should be fine. Now, in order to get through this piece of plastic, you need to do some trimming. So I'll show you how that works. Pull this whole piece out, and you'll see that I have trimmed down this part here, down to that level there, and on the other piece I have trimmed down that much there, so that just using a Sharpie, so that the wires can come through. And it doesn't need to be quite as wide as I cut it. And you'll also see I've trimmed a little bit of this catch as well, so that it doesn't pinch there. It didn't need to go that wide. So you'll need to, before you stick it down, you'll need to line it up with this shroud so that it fits in there quite nicely, and then clamp it back in place. Then that goes back in place nice and carefully, and try very hard not to break any of the clips. And then that goes back in there, nice and easy. That flops back into place and push it like that. Then that screws in there. Now, when you get to this part here, you'll need to thread this down through the innards, and before you start doing that, it's worth opening up the underside of the dash so that you can get through. Okay, so we're wanting to pull this panel forward in order to get inside, and in order to do that, on a right-hand drive car of 2011 with latches for the charge port. This is my 3D printed latch. If you ever break your latch, you can 3D print one. So you'll need a 10mm head hex socket to undo that, and another one. Undo that, and you can pull that forward, that whole chunk forward, and that reveals a T15 Torx. Now, I have seen some cars just have a Phillips, which is much less annoying. So undo that, and once you've done all that, you can pry this loose. Let's zoom back. So you want to stick your pry bar in here and lever forward, and then you can yank that down and it flops like that. And then over this side, you want to stick it in wherever you can find fits, and lever that forward, and that gives you enough room to get into where I've already got this one located. So we've got cable from here flops down through here. Where is it? There we go. And you can mount it either in here, like I have there, or you could put heavy duty Velcro on the bottom and mount it here under the steering column, out of the way, but still with the USB port nicely accessible should you wish to play with the software. What I often do with this one is I have a USB cable permanently plugged in and just wrapped around the steering column so that I can program it without having to go into the dash every time. Oh, the other thing you might want to know about is you can buy these Ov2 Splitter Cables. That's what I've got going on here. I've got the original Ov2 cable plugged into one of these and then going off to the standard Ov2 location and also to this slot here, which in Japanese Leafs used to be taken up with a toll road payment device, card reader thing. So I've got a 3D printed thing where you can replace that device with another Ov2 port, because you can never have too many Ov2 ports. That allows me to have this plugged in and then also plug something in for Leaf Spy. Leaf Spy has really nice logging functions, Leaf Spy Pro. The other thing that's worth knowing is that this gadget, it reads and listens to the CAN bus. It never sends commands to the CAN bus, so it's completely passive. Otherwise, you just throw everything all back together. The dash slaps in like that. You reverse the process here, and you're good to go. So this one first. And that goes like that. Alright, then that goes like that, that goes like that, and ta-da! Oh, look at that, it's like it's meant to be. Alright, well, thanks for watching, and I'll catch you next time. Cheers!